Hello everyone. In this lesson, we will learn about operations of complex numbers. There are four basic operations: addition, subtraction, multiplication, and division. However, in this short unit of complex number, I would like to summarize the operation of complex number as follows. If you have to add or subtract the two complex numbers, then the best way is to put them in rectangular form. Once they are in rectangular form, you can perform the operations algebraically. Alright, so if you have to multiply and divide the two complex numbers, then you can use rectangular form as well, but the concept is a bit more complicated, involve a lot more algebra. So I would like to simplify the process by asking everyone to put your complex number in polar form. Then you must follow the following rules when you multiply and divide two complex numbers. So at this point, I am hoping that everyone has already reviewed the complex number in rectangular form and in polar form. Okay, so let me quickly write down what is the complex number in rectangular form. Rectangular form, you should have the real part, which is x, and the imaginary part, which is y, and you attach that with the j. Okay, so rectangular form has the imaginary part and the real part. Polar form of complex number are represented by the modulus r and the argument theta. Okay, so I will go over these two rules later in this video. And at first, I would like to concentrate on addition and subtraction of complex number and using rectangular forms. Okay, so example number 1. This example asks me to perform the indicated operation, express the final answer in rectangular form and in 3 significant digits. Okay, so this particular example, if you take a closer look at it, it's actually very simple, right? Because they are in a rectangular form already, and if you think of it as interval algebra, all you have to do is just collect the like term. And before you collect the like term, you just have to use distributive rule. It means that you may want to consider multiply this negative inside the brackets here. Okay, so let's do that. Okay, again, let me repeat this. Right, so you have two complex number. This is one complex number in rectangular form. You have another complex number in rectangular form, and you're supposed to subtract these two complex number. And the rules is you just have to perform using algebra. So, and then it's actually very simple by just thinking that I'm going to collect the like term, simplify and collect the like term. So I will put 2.75 plus 1.62j. I subtract 1.25. Okay, negative times negative will give me a positive 1.3aj. Okay, so collect like term that I should do this. I should take these two numbers, subtract. Then I should have the answer as 1.5. And the next like terms would be this 2 with the j. So if I combine these two, my answer should be plus 3j. Alright, so now we haven't finished yet because this question asked me to write the final solution in 3 significant digits. Okay, so here, 3 significant digits. I posted a video in Blackboard and asked everyone to review the concept of significant digit and rounding to certain significant digit, because we have to use the concept throughout the entire course. So it's a good idea to review that. Alright, so 1.5 is doesn't have 3 significant digits yet. It only has 2 significant digits. So to present this as 3 significant digits, I must write 1.50. Okay, and for number 3, it's only 1 significant digit, but I need to write 3 significant digits, so I need to write 3.00J. And the question asked me to express the final answer in rectangular form, so I am good. Alright, okay, so let's move on to the next example. The next example, I am asking everyone to subtract this 2 complex number, and this 2 complex number happens to be in polar form. Okay, so ask yourself this question: is there any rule for me to subtract 2 complex number in polar form? Okay, so let's go up here. The rules are, pay attention to this. Okay, here you have to multiply the 2 complex number. Right here, you divide the 2 complex number. These 2 rules involving complex number in polar form, you can only apply it to multiplication and division. So if you add or subtract complex number, there's no way that you can apply any rule for this, except that you have to convert this 2 complex number to rectangular form. Okay, so we need to convert this complex number into rectangular form, and from that rectangular form, we can just use algebra to work with. Okay, so to do that, I will give everyone the answer for this complex number in rectangular form, because I am using my calculator, Casio FX991MS, the one that you have. And in previous lesson, you already learned how to convert between rectangular and polar form using that same calculator. So in this lesson, I can only provide the answer because don't forget, I only have 30 minutes to complete. Okay, so what I will do is I will write down 4 decimal places that I saw on my calculator, because with 4 decimal places, I can have more accurate answer at the end, because I have to then convert it into polar form as well. So it's best that we keep 4 decimal places in our calculations. Okay, so when I convert this complex number, 8 as modulus, and 27 degrees, don't forget it is a degree, in 3 significant digits, and also in for the argument of 27 in 3 significant digits. Okay, and here I should mention this. When I said it's degrees, it means everyone on your calculator, you must put your calculator in degree. Okay, so don't put your calculator in the radian mode. And it's a good idea that you should turn off your engineering notation. In working with this type of complex number, I think it's best that we turn our engineering notation off. Okay, so now the next number I would like to provide for everyone is this number right here. When I convert 9 and 80 degrees to complex number in rectangular form, I should have this. Why I am writing this down, I would like everyone to use your calculator and review all the steps how to convert your complex number from polar form to rectangular form, and then check to see if you see this two complex number in rectangular form like I'm written here for you. Okay, so if I use algebra, again, I use algebra, I break this brackets open, multiply the negative inside the brackets here, and collect the like term. I should have the answer as 5.5653 as the real part for this complex number in rectangular form. The imaginary part will be 5.5653 0.2314J. Alright? Okay. But this question asks me to express final answer in polar form. Therefore, again, I have to use my calculator and convert this into polar form. So when I convert into polar form, I will have the modulus as 7.6381. I will write 4 decimal places. Then I will round to 3 significant digits at the very end. Okay? And the argument the calculator gave me as 43.2286. And don't forget, my calculator is in radian, it's not in radian, I'm sorry, in degree mode. Therefore, you have to write this one in degrees. Okay? So make sure you switch and activate the mode so that you can get a degree on your calculator. Now, again, I have to round it to 3 significant digits. So rounding to 3 significant digits, I should have the answer as 7.64, and the argument will be negative 43.2, and don't forget to write the degree sign. Alright, okay. So if any one of you puzzle about rounding to 3 significant digits, okay, I can quickly review right here for everyone. Okay, so from this number, alright, okay, 3 significant digits, it means that you have to round this number 3. Rounding number 3 is mean you are going to look at 8. So the next significant digit to 3 is 8. So 8 is greater than 5, so you have to increase the 3 by 1. So that's why you have 7.64. Again, in this argument, this is your third significant digit, and you have to round it. That means you have to look at the next significant digit to it, which is number 2. So 2 is less than 5, therefore you drop the rest of them and you don't increase the 2 by 1, and your final answer will just be negative 43.2. Okay, so let's go over the multiplication and division. Okay, so when you need to multiply and divide, it's best to use polar form. The reason I pause is this. When you multiply and divide two complex numbers, there are rules for you to just perform these two operations using rectangular form as well. So you don't have to stick to polar form to multiply and divide two complex numbers. However, to simplify the process in this class, I recommend this rule. Okay, so multiplication, division of two complex numbers, you can just leave them in rectangular form and apply algebra to simplify and perform the operations. However, those are not covered in this class. They can be very complex, and we don't have enough time to cover. We have to go over the concept of conjugate, and we have to factors. We have to make sure that we expand correctly. So therefore, it's best to stick with polar form, and it's actually very simple. So why don't we keep things simple? Because why do we learn complex number for this math class? It's because we need to use it for our applications. The application that you are going to learn later on in this unit is actually how the complex number apply to the alternating current, which involve resistor, involve your inductors, and involve your capacitor. Is called AC ILC circuits, series and parallels. So if we master the complex number, and we know how to perform all the 4 basic operations, we should be fine by and make the process easier for us to solve for the applications. All right. So okay. So let's get back to this rule. Okay. So at this point, everyone remember that polar form of complex number is the modulus r and the argument theta. And I emphasize again that theta is in degrees, okay? And the modulus r is more like a phasor or the vectors, and is the magnitude of that vector is actually your modulus r. Okay, so I present the first complex number as r1 theta 1. Alright, okay, r1 theta 1. The second complex number will be r2 theta 2. So right here we need to multiply the two complex number. So what you need to do is you are going to multiply the two moduli. Okay, modulus 1 multiply modulus r2. But what happened to the argument? The argument, you have to add the two arguments. Okay, so pay attention to this. It's simple, but it's just something we need to remember. Okay, so you can only multiply the two moduli, but you have to add the two arguments. So when it comes to division, so what do? We divide these two complex numbers. Okay, r1 theta 1 divided by r2 theta 2. So that means the division, we need to divide the two moduli. You take r1, you divide it by r2. But when it comes to argument, you need to subtract the arguments. That means the argument as the numerator will subtract the argument as the denominator. So that's why I am writing the two complex number as division in this form. Okay, so keep that in mind. So let's apply it to our example number 3. So we perform the indicated operation, express final answer in polar form and in 3 significant digits. So first of all, okay, like I mentioned earlier, some of you may just like, okay, I'm good at algebra, I'm going to expand this, I multiply them out, I apply j squared equal to minus 1 and to get the answer. But honestly, I want to emphasize the rule that I need to convert this into polar form, and then I will multiply the two moduli and I add the two arguments. At the same time, everyone will have a chance to review how to work with your calculator, convert from rectangular to polar, right? Okay, so let me write the answer down for this. If I use my calculator, I convert this into polar form. I should have 5.6586. The argument will be negative 133.5679. Okay, so then I multiply this with this complex number. This is 7.9057. Argument will be negative 71.5651. So I work with 3 significant digits at the end. I have to round to 3 significant at the end. So it's a good idea to keep 4 decimal places in our calculation so that we are consistent. All right. Okay. So now apply this rule. Okay. So I'm going to apply this rule. I am multiplying two complex number in polar form, so I will multiply the two moduli here. So like this, and multiply that. So when I multiply that too, so I'm going to write here that I'm going to multiply. Okay, multiply. So when I multiply, my answer is 44.7352. Okay, what about the argument? I need to add the argument, alright? Okay, so let me write this in different colors. So the two argument, I need to add the two argument. So when I add the two argument, my answer is negative 205.133 degrees. So if you want me to give you the 4 decimal place here, so it's in fact it's just A0. Okay, so now we have our answer in polar form, all we have to do is just round to 3 significant digits. So rounding to 3 significant digits, it will be 44.7 in this case. And for this one, I should have negative 205 degrees. Alright, okay. So let's move on to the next questions. Okay, so next question. Again, I repeat the rules here for everyone. So in this case, I kind of mix them together. I have the operation for a plus right here. Okay, I also have the operation for dividing two complex number, and these two complex numbers are in rectangular form. Okay, so I think it's best that we convert these two complex number into polar form, and then we can apply these rules. Okay, so let's do that. Okay, and before I do that, I would like to ask everyone to pause a minute and then analyze the question that they asked us to do. So you have this complex number. Okay, follow my cursor here. This complex number is in polar form. Right. Then you have to add that with this expression right here. So according to the very basic, I'm very sorry. I think I need a sip of water. Okay, thank you. I just have a sip of water. According to the very basic rule in mathematics, everyone, when they first learn mathematics, you have to learn the order of operations, which is BEDMAS. All right. So in BEDMAS, you have to use brackets, exponent, division, multiplication before you can add or subtract. Okay. So this basic rule applies to complex number as well. Why am I emphasizing this? Because you will have to perform all kind of operations with complex number later on. Okay, so in this case, I need to perform this operation first. So I would like everyone to pay attention to my cursor. Okay, so I need to perform this operation first. I have to divide first before I can add this with this complex number. So if we analyze it, you see this is in polar form. So if you have to add to this, it means that you need this complex number in rectangular form. So I might as well do that right away. So I will convert this complex number in rectangular form by writing this as 4.16. Wow, it's a lot of 9, so I might as well write all the 9. And then I add that with 4.25A3J. Okay, so again, please practice using your calculator. Master all the steps of what to do when you need to convert from polar to rectangular. Okay, so my next step is I am going to convert this number into rect. Okay, convert to, oh, it's rect, so I need to convert that into polar. Okay, so it's rect, so therefore I convert that into polar. So basically that's what I would like to remind everyone. So then I should have 10.0454. The argument will be 124.9873 degrees. Underneath, I convert this, I should have 10.1796. My argument will be negative 49.0629 degrees. Okay, so I'm going to perform the next step here, which is I will take these two moduli, I divide one into the other. When I divide this, I should have the answer as 0.9868. Okay, so can you pay pay attention to this number. So I want to show you this number 10.0454 and 10.1796. Do you see that they actually very close? Okay, very close to each other. And if you round too much, you may end up with maybe just a 1 here, which is very not really accurate, right? Okay, so the argument, right? The argument is when you have to take the argument as a numerator, you subtract this argument. Okay, so when you perform that operation, don't forget it's a negative here. Okay, so you subtract a negative, it turns into a positive. So my answer is 174.0502 degrees. Okay, so what I have to do next is, because I have to add that with this complex number, therefore I need to convert this into my rectangular form. So when I convert to rectangular form, I end up with negative 0.9815. Add that with 0.1023J. Okay, so now I am going to add that with this complex number in rectangular form as well. Okay, so if I collect like term, then my answer will be 3.1885 plus 4.3606J. Okay, and did they ask us to convert to polar form? Yes, I convert to polar form. I end up with this number. Okay, 53.8255 degrees. But I need to round to 3 significant digits. So 3 significant digits would be this. And this one should be just 53.8 degrees. Alright, okay. So basically, in this example, I would like everyone to pay attention to the concept of BEDMAS. Okay, BEDMAS apply to complex number as well, and you need to convert to polar form so you can apply this rule. Divide the two this modulus into this modulus, or subtract the two arguments, okay, and then convert to rectangulars so that you can add the two complex number and the end convert to polar as required. Alright, okay. I have a few minutes left in this lesson. And honestly, why do I need to go through all of this? Because we need to apply this in calculating the LC AC circuit. Okay, so I would like everyone to take a look at this document that I'm going to show you next. It's actually in our workbook, okay, in the workbook that we have for this unit. If you take a look at this workbook, so let me go back and tell you what I mean by the workbook. You see, this is our lesson 1 completed here. So this is the workbook that I'm talking about. Okay, we finished lesson 1 already. Okay, basic rule, how to convert rectangular to polar. What does it mean by a complex number in rectangular form and in polar form? Okay, so this lesson is very important. Okay, you need to use your calculator, Casio FX991MS, and learn how to perform operations of complex number using your calculator. So therefore, you need to go through all of this step. I have everything here. I need everyone to go over it yourself, and then try this example, try all this, also try the practice lesson. But you don't need to apply all the basic rules that I just showed you. You can just use your calculator to work with. And where do you find the answer for this? Okay, you see this number 2 is very complex, but you can perform using BEDMAS, and you can use your calculator to work with. And you can find the solution for that practice, and I posted it right on Blackboard, and I explain everything right here. Okay, so um, I'm 30 seconds now.